So in terms of the effect of this technology to the environment, of course, it's not, it goes without saying that there will always be an effect on the environment, especially if you look at the efficiency of the solar PV is quite low. And this is only for solar PV, and even for CSP also, it's not that high. But at the same time, it uses a lot of land area, a lot of land use. And the bad thing about the solar PV, if you compare this one with the wind farm, for example, is that solar PV in most cases you cannot really use anymore the area that it is located for solar farm, for example, because it is covering the whole of the area and it's not very high. So it means that you cannot just graze some domestic animals here for that purpose. So there is a concern for land degradation and habitat losses because it cannot be used for dual purposes, unlike in wind farms where you can use the land below the wind farm, for example. So in this case, because of the low efficiency, we need a very large land area as well. So as an example, to just give you, a scale of how much land area we are using, for these around 1.4 to 4 hectares of land area per megawatt of electricity generation for solar PV, while for concentrated solar power around 1.6 to 7 hectares. So this is more land area for concentrated solar power, and so we have to reconsider that one. The good thing in Australia, we have so much land space available, so it's a good thing, but it's also far away from the civilization. So it means that we need to provide long wiring and long grid systems in order to tie up with the grid, and this means that there are more expenses available that will be needed, as well as losses along the way. So unlike wind facilities, there's less opportunity for the solar project to share with land with agricultural uses. So this is a disadvantage and could be an impact towards the environment as well. So the best way to address this one is to make sure that the place that you are going to put your solar farms would be somewhere that is low quality locations, so it will not trouble other agricultural, for example, agricultural lands should not be troubled. So you can use some brownfields or abandoned mining land as a way of putting up these solar cells. Also, we can utilize our homes and buildings and civilization or urban setting to put up some solar cells on the rooftop. Another important factor that could be an impact to the environment is water use. For solar PV, it's not much of a concern because there's no moving parts for solar PV, but during the operation, but during manufacture, it could be use some of the water because when you use some semiconductors, the mining, for example, you need to use water for that. But if you look at concentrating solar thermal plants, or CSP, or solar power, then this requires a large amount of water for cooling because we use heat exchanger here. So in this case, just like a conventional fossil fuel power plant, which we use cooling water to cool down the heated steam, then we need about 2,200 to about 2,500 liters of water per megawatt hour of electricity produced. This is a large amount of water actually. So this has to be considered because, especially in Australia, that we have some problem with water scarcity, and this is one of the driest climates in the world. So it has to be considered overall. It has to be using probably a low quality water coming from the sea, from the river, for example, but making sure that the discharge of this water could also possibly destroy or make some changes in the area of discharge. So we have to be very, very careful about discharging as well of the used water from the CSP. So another environmental impact for the solar power generation based on the PV and CSP is on hazardous materials, and this is mainly pertaining more on the solar PV manufacturing, because when we are manufacturing coming from some rare earth metals or for silicon, silicon processing, we need to clean and purify these semiconductors. And when we use this purifying and cleaning, it means we need to use some acids or some cleaning solutions. And these chemicals will be quite detrimental to the environment, to you, to the health as well. So it has to be careful because these are hazardous materials that would affect the health of the people, and especially during discharge. Also during the manufacturer, there's a potential of inhaling some silicon dust to the workers. So the main hazard for this one is on the handling of the materials themselves. So it has to be careful about this one as well. Another factor for environmental impact is that because solar PV, for example, has very low efficiency, it means that in order for it to produce large amounts of electricity and large amounts of power requirement, we need to also provide a lot of materials to produce this one. So we have to manufacture a lot of photovoltaic infrastructure. So this means that the more materials that we are spending, the more money that we're spending, we are also contributing towards greenhouse gases, because money is equivalent to carbon dioxide emissions as well. But of course, in comparison with the CO2 emissions based on the coal and other energy technologies, the solar PV is still relatively lower compared to much lower compared to the coal, if we consider the manufacturing, not only the operation, but it's much higher also compared to other energy technologies like the wind energy, for example, or even geothermal, even hydroelectric. So solar PV, because of the use of very specific materials, so that's why the CO2 is quite at this range as well. But in terms of LCOE, solar PV is almost at grid parity now. It has increased a lot. So solar PV is also here around 0.125. It's almost similar with wind. And then coal is around this area here. So it's almost similar at this point. And the more uptake with solar PV, then we can really feel the grid parity of the prices with the fossil fuels.